So that's all fine and dandy. I'll see how my other markers are working right now. That kind of break off. Oh, they're back. Nice. Let's throw these out too. Not bad. So let's look at an example now. So you have, this is the BR2 clearly. You add equals 1, 1 in R2, right? Then the length of that vector, which is simply equal 1 squared plus 1 squared, which equals root 2. That's it for the length of vectors, right? And in R3, if this equals all you have is which equals root 3. We'd have that in R3. Okay. So this properties in terms of length of these vectors are over. Unless you have a zero vector, your vector is always going to be greater. Your length is always going to be greater than 0. It's always greater than 0. Unless your vector is a zero vector, which is just 0, comma 0. Or in R3 it was like, that's R2. Or like that in R3. Because then the value clearly is just 0. Nothing too crazy. So if you have like a constant side, right? What we can do is factor that constant out almost. Let's multiply the constant in. Do that R is the element of real numbers. Okay. So, cool. So if I had this, right? We would just have this, right? Multiplied by the length of that vector. Common mistake is that they pull it out as -2. So you just have 2 times the magnitude of this vector. Okay, that's what you have. Alright. Now, that being said, if A and B are 2 vectors, then the length of A plus B is less than or equal to the individual sum of the vectors. That's something to get down in your notes. Okay? So we call that triangle inequality. Okay. With the distance between 2 vectors, what are we going to talk about for that? Well, glad you asked. So, distance between 2 vectors. Well, that's the case, then AB would equal, which also equals B minus A, because you're taking the absolute value basically. kind of like an absolute value kind of vibe. So you have A equal to, and this would be an arc 3 clearly because there's 3 points, and B equal to 0, 2, and 3, right? The distance between A and B is just going to be that. So then you get one squared plus 0 squared plus minus 2 squared. And you get root 5 as your answer. That's what you get. That's fine, dandy. Okay. And there's a statement we make that the distance between two vectors is always a non-negative real number. We're going to talk about now the dot product. The dot product. So dot product. So you have this vector, let's say. You have this as y1, y2. What you have, these are two vectors in R2. The dot product between x and y, you write it like this, that's really a dot. It's like kind of like multiplication kind of vibe. How you write that is the dot product between the two just equals x, y plus x2, y2. I'm multiplying them. And the dot product, just like earlier, that previous statement, not just the dot product, it's the distance, but the dot product is always a real number as well. In R3, we get the same idea, right? In R3, you get something like this, right? 3 points. So, dot y. It's kind of like multiplying the points almost, just adding them together. That's all you're really doing. So if you have this, right? We're using an example of R3, nothing too crazy. And we have this, right? Then x dot y just equals get 9. That's what you get. Let's talk about some properties of the dot product. Properties. In R to the n, it could be R2, R3. So A dot A equals that squared. That's property. if you have, so you have A equaling A1, A2, and A3, then A dot A would just equal A1, that's A1, A2, A2, A3, A3, kind of like that. And you'd end up with like that. That's what you'd get. A dot B equals B dot A. A dot B plus C equals A dot B plus A dot C. Distribute it almost. That's what you can do. Also, if R of A dot B, you just go ahead and write that as R A dot B as well. And what's the formula for A dot B? Well, glad you asked. All it is, okay, is that A dot B is equal to magnitude A multiplied by magnitude B cos theta, where theta is the angle between A and B. That's the definition. Okay. That's what theta is, the angle between them. So in R2, right? It's R2. You have B here. You have A here. Right? This is the angle between them. Okay. So A and B are perpendicular. Or orthogonal. So the term orthogonal. A and B are what we call perpendicular or orthogonal if the angle between them is pi over 2. Because cos pi over 2 is equal to 0. That means if it is perpendicular, A dot B is indeed 0, because you're multiplying all these values. So you get 0. So if we were trying to find the angle between the two vectors, that's a common question that we could ask you on exam. Then, sure, you're like, bring it on, let's do it. No problem. Okay. So since A dot B equals A and B cos theta, right? You have that. What happens is that this equals this, and this equals okay. These both equal root 2, by the way. So what happens is that you get and by the way, A dot B, if you were to actually kind of multiply all the points, you just get 1. So 1 would have to equal root 2 times root 2 cosine theta. In other words, cos theta equals, well, 2 cos theta equals 1. So root 2 times root 2 is indeed 2 by itself. Meaning that cos theta equals a half. And that would be theta equals pi over 3. So that basically sums up the note in essence. We're going to do one more example for the road where you have two vectors, you have to solve for an unknown within the vector. So if we're given the fact that A is this vector, literally just this R3, 1, 2, and 3, and B is 1, R and 2R, right? You want to find the values that make them orthogonal to each other. Meaning by definition, we have to have the two dotted to equal 0, essentially. So you'd have 1 plus 2 dot r, because it'd be 1 dot 1 plus 3 dot 2r, which equals 0. Because they're perpendicular, the dot product between them is indeed 0. So you'd have literally 1 plus 8r equals 0. So r through algebra would equal -1 over 8. That would be your final answer.